Everybody, today I'd like to introduce Stephanie Eckman to the GESIS lecture series. Stephanie holds her PhD from the Joint Program Research Methodology. She has worked for the Institute for Employment Research in Nuremberg and at the University of Mannheim. She is currently a fellow at RTI International in Washington. At the moment, she's visiting us here in Mannheim. And she visited us for the GESIS summer school and to work on 2 projects. The first project deals with motivated underreporting in mobile surveys, and the second one is focused on the link between non-response and measurement error. So today she will give us her talk. In her talk, some exciting examples of how we can supplement survey data with passive data.
Okay. Thank you very much, Jessica, for the introduction. I just saw Florian walk by, the other going the wrong way. Can you text him? Do you have his number? Thanks. He was like very like in a hurry, but totally going the wrong way. So hopefully he'll join. There's one more seat left for Florian, so that'd be great. So thanks for the introduction, Jessica, and thanks to everybody for coming and standing. I appreciate that. I'm going to talk today about 3 different studies that I'm currently working on relating to the combination of passive data and active data. And all these, yes, Florian will be here. He'll feature nicely in the video as he comes in. These are all works in process, so I'm happy to take some input and get some thoughts from you guys about what you've seen and what you're researching that might be similar or related. And I don't have like definitive answers to any of this research yet. It's very much ongoing. So I hope we can have a nice discussion. Florian, are you gonna? Florian, everybody! Okay, and here we go. So I want to prepare us in this room and those of us working in the survey research field for the changes that I see happening in our industry. So right now I'm working for RTI International. I used to be in Germany working in Nuremberg for a while, but I'm now at RTI, and what we do there is a lot of these large government surveys, right? The kind of surveys that take a year or 2 to plan and then to collect the data and to prepare the data on the other end. These are long, often very lengthy instruments, an hour or 2 in someone's home. A lot of them are face-to-face surveys. Our clients are demanding high response rates. At the same time, their budgets are shrinking, so they are, they're asking us to do better with less money, and they of course want random samples as well. And so this is a traditional, what I call the traditional survey model. And to me, this model seems in crisis. As I said, all of our clients' budgets are falling, response rates are falling. I don't think we continue to do surveys, for some of our clients at least, in the same way that we have been for the last 20 or 30 years. There's going to be some changes coming. And so I'm doing this research on passive data to get, so that when our clients are ready to make the jump to alternative forms of data collection, we have some information and some knowledge that we can share with them. Not all of our clients are going to be ready for passive data in particular, but I want to be able to offer a broad range of alternatives. So that may mean non-probability samples, shorter surveys that are maybe chopped up into pieces and different pieces administered to different sets of respondents. We're going to have to offer high incentives. We're still going to get low response rates. I mean, in Germany, you guys are ahead of us in low response rates. You're leading the way. So I want to help our clients get comfortable and move on to this new model in many cases. Let me just pause and define what I mean by passive data. So in a survey, we ask the respondent questions. Are you currently employed? How many children do you have? Did you vote in the last election? So we get information from people in an active way. We're asking them questions about their lives and their beliefs and their behavior. Passive data is getting similar pieces of information, but without having to ask questions. And I'm going to give some examples of how that would work. So the first source I've seen on passive data is this book from 1971. This is a really interesting book. They don't use the term passive data. They call it unobtrusive measures or non-reactive research. And so they think about, in this book, how could you test a sociological theory that you have without collecting data, without going through that expense? And there's some really nice examples. So for example, if you have a town where drinking is outlawed, there are no bars, but you wanted to know, do people drink anyways? That's the kind of question that'd be hard to get in an active way because people might lie, they might be embarrassed, right? But in a passive way, you could dig through their garbage cans and like see if there's empty whiskey bottles or beer cans in there, right? So that's a passive way that you can get data about people without having to ask questions. Another example would be if you wanted to know, from the book, if you wanted to know which museum exhibits were most popular. Well, you could count people every day who are coming and going, or you could ask people which ones they liked, or you could consult the maintenance log and see where the floor tiles needed to be replaced the most often. And that would tell you which exhibits were most popular. So these are the examples. I would call these macro passive data because they offer a good sense of one measurement, but they don't give us a lot of covariance. So for example, about the drinking, you might find liquor bottles in someone's trash, but you don't know which member of the household it is that's drinking, if it's the teenagers or the adults, right? So you don't have those kind of covariates that we like to have in surveys to study phenomena. So the passive data that I'm working with and that I'm going to be talking about today is micro-level passive data, where I have some active data about a respondent, and then I also have passive data, and I can line those two up. I can merge them together. There are a lot of different forms of micro data that we can get today. The ones I'm going to be talking about today come from the sport watches or the jawbones, the step counters that some of us wear, and also from our smartphones, of course. I think that's the most common source of passive data these days. So I'm going to be addressing this research question: can passive data help us make our surveys better? And by better, I mean shorter, higher response rates, lower cost, and hopefully better data quality as well. This is a yes-no question. I'm not going to give you an answer like yes or no, but I'm going to show you some of the research that we're doing to address these points. My research is a step towards figuring this out, and maybe some of you are doing research in this way as well. I'm going to talk about 3 different studies that I'm doing that you see here. And the first uses what I call always-on location data. This is a smartphone study. And by always-on location data, I mean that we know where that phone is at all times, right? Whether you're in the app taking a survey, or you've put the phone down and you've gone to sleep, we're getting location data from that phone at all times. In the second study, we have what I call in-app location data. So there's an app on the person's phone, and we know where they are when they're using that app. But if they're not in that app, then we're not getting the location data from them. So like the Uber app. I don't know if Uber is real popular in Germany. It knows where I am at the time that I'm calling for a car, because it has to know where I am, right, to pick me up. But if I'm not using the app, the Uber is no longer tracking my location. And then the third study uses fitness data. There's very important issues that I'm not going to have time to talk about. These are not issues I'm currently researching. Perhaps some of you are doing this. Other people are looking into these issues. I just want to make it clear I'm not going to get into these important topics today. So I'm not going to look at consent to passive data, right? Who will allow us to get this location information or the exercise data from their watches? I'm not going to look at that. These are all non-probability samples, and I'm not going to be making inference from these to a larger US population or anything like that. I'm really just exploring the samples that I have themselves. And I'm not going to talk too much about the ethics of passive data. We can have a discussion about that. I think it's a really important issue, but I'm not going to get into that today. So the first study is about augmenting survey data with always-on location. This is with a bunch of RTI colleagues here. And for this study, we did a convenience sample of our RTI employees. So these are just people in my department who happen to own iPhones. So I can't make any inference from this group to any larger group. And what they did is an intake survey. So they went onto the web and filled out a bunch of information about themselves, demographics mostly, how do you get to work. Then they did a daily survey every day for 2 weeks. And then they did an outtake survey at the end where we asked, how did you enjoy this experience? What did you think about it? And so they were doing these 3 surveys, or all these surveys here. And then I was also getting passive data. We put an app on their phone called the Moves app that was tracking their always-on location data. It has some sort of algorithm such that if your phone is not moving, it no longer is, it's not continuing to drain the battery to figure out where you are, right? The Moves app, we found it very useful. Don't go looking for it. Facebook bought it a few years ago, and they just killed it a few months ago. So this app is no longer available, unfortunately. But from this app, we have a bunch of coordinates about our respondents. The coordinates are of two different types. There's traces and places. And we're just looking at the places, which is like, where did they stop, right, and spend some time? So we're all here. We've all got our cell phones with us, and this is now a place where each of us stopped and spent some time. Okay, so we've got about 5 places per person per day. And what I'm really interested in is, can we use that location data to figure out things about people? So here's what the data looks like. This is one of my colleagues and his data over a 2-week period. The gray there is where he went outside of work hours, and the black is where he was during work hours. So you can see that this guy lives in Chapel Hill. This is North Carolina. So he lives over here in in Chapel Hill, where we see all these gray points, right? And he clearly works over here in Research Triangle Park. He works at RTI. If we were to zoom in, we could see exactly what building in RTI he works in, right? And if we zoomed in over here, we probably could figure out where he lives based on where most of those flags are. It seems like maybe sometimes he works from home, maybe sometimes he doesn't make it to work by 9 o'clock because we've got some, or maybe he stops here for a coffee, something's going on, right? So we can begin to paint a picture of what kind of person he is. What is the kind of person who lives in Chapel Hill? And that immediately tells us some things about living in Chapel Hill versus living in Durham or one of the other towns, right? Here's another example that we saw in our data set. I really like this example. This is the Moves data telling us the means of transportation here, right? So this is somebody who was at the RTI campus. Is my pointer going to work here? Okay, so this is somebody who was at the RTI campus, walked to their car, got in their car, drove to the airport, and then for some reason their phone turns back on or so somewhere over South Carolina. And they flew to Orlando, where they again walked and got into a car and drove to a hotel. So this tells us things about the person. I'm not so interested in the fact that this person took a trip to Orlando, but what does it tell us about them? I mean, Orlando is where Disney World is. So it suggests that they have kids. It suggests that they make enough money that they can afford to go to Orlando in, I think it was February when we did this study, right? We can see what hotel they checked into. That tells us also something about their income level. So we can start to see some things about this person. I'm just trying to give you a sense of what's in this data, right? The data itself, the traces of the places data, is nothing but like latitude, longitude, timestamp. Latitude, longitude, timestamp, right? But using those, we can make these kinds of graphs and start to think about what we can learn about people from these sort of data. Here's another example. Oh, that's not going to work. Here's another example. This is somebody who went to Target. If you guys know Target, it's like a Walmart. It's like a sort of a big superstore, right? So we can see that they probably parked their car and walked around here for a while, and then they went inside Target, and then they came back out over here. Again, this tells us something about the kind of person they are, the kind of person who shops at Target rather than Walmart or other kinds of stores. So what I'm really interested in is, what can we extract from these coordinates? We can probably tell where someone lives, and in the US and also in Germany, that's correlated with your race and your income and other things about you, right? We could probably tell whether that person visits a daycare or a school, which suggests that they have kids. And we can probably tell where they work and what hours they work. Now, some people work from home. It wouldn't, be completely accurate, but we can start to get a sense of their work hours. I think we could also tell some things about their exercise behavior. So there's walking and biking on that transport list, right? If you bring your phone with you while you go out exercising, we have some data on that, right? If you take your phone when you go to the gym and lift weights, we have some data on that. We can see that in the data perhaps as well. And we can probably tell religious service attendance. because if you bring your phone with you when you go to service, then we're going to see that in the data. These first three, sort of above the line here, right, are things we could certainly ask people. Are you currently employed? What hours do you work? Do you have kids? We can ask these things. Those aren't difficult questions to answer. They are a little boring, and they make our surveys just a little bit longer when we ask those questions, right? So maybe if we can figure this out without asking, the survey is that much shorter. Exercise behavior and religious service attendance, on the other hand, we could ask these as well, but we know that these things are poorly reported in surveys. People tend to report how often they mean to exercise, right? Or the fact that they intended to go to church last weekend, but they didn't, right? So the data we have on these from surveys is full of social desirability bias. And so if we could get these out of the location data, we'd actually make data quality better on those variables. So we tried this. We matched each of the coordinates, those places, to 3 different sources of point of interest data. So Google, Foursquare, and Yelp. Google, we all know that they know where the restaurants are and stuff. Yelp does a lot of reviews of restaurants and hotels and other things. And then Foursquare is a community where it's more of a user-generated community. You can check in at a certain place. You can check in and say, hey, I'm at this cafe. Foursquare has a lot more places than the other two, probably because it is user-generated. It contains things like Paul's apartment and break room at work, right? Some things that we're not particularly interested in. But they do all have these businesses that I would like to be able to match to the respondents. So 29% of our coordinates for our respondents didn't match to anything in any of the databases. Suggests to me that they're probably homes, right? Because most people's homes, aside from Paul's apartment and Foursquare, most of our homes are not in these databases, so they didn't match. Then for the remainder 70% of coordinates, I had way too many matches. I just kind of returned a bunch of things within 1 kilometer, and Google and Yelp and Foursquare had more than 10 places for each of these coordinates. So I brought it down to just the closest from each one, the closest Google match, the closest Yelp, and the closest Foursquare. And even then, there was a lot of disagreement, which I found very frustrating and surprising. But for an example, there was a given coordinate, and Google told me the person went to a grocery store. Yelp told me they went to a liquor store. Now, liquor stores and grocery stores, they might be, co-located, very close together. And then Foursquare told me it was a dentist office, which leaves me really, unable to tell what's going on there, right? So this whole process didn't work as well as I wanted it to. They did tend to agree, the databases, on those large places. So like that Target we saw on the other slide, which something, or like a airport, right? Those would match across the databases. If it's something really big, they tended to agree on that. But things like seeing if they went to a daycare turned out not to work as well as I would have liked. So I hand-coded all these as to whether the location given in the databases seemed to be a daycare, a grocery, or a gym, right? So on the vertical axis here, this is how many visits I found in the 3 different databases. And I'm just grouping all the databases together here. Did any of the databases suggest a daycare, a grocery, or a gym? And on the horizontal axis, we've got the number of reported visits to those places in that outtake survey, that web survey they did at the end of this study. Now, recall is not the best way to do this, to say how many times did you go to the grocery store over the last 2 weeks. It's not exactly the best way to ask that question, but I didn't want to burden my colleagues in this small pilot study with a real travel diary study where all the places you went today and tomorrow, nobody would have done it for that if I had asked for that much. So I just asked, how many times did you go to daycare, grocery, and the gym? And, if this worked, we'd see all the points lined up on these 45-degree lines, and that's not what we see. Respondents reported going to daycares, but we don't really see that in the data, just 1 visit in the data. In the gym, it's kind of all over the place. We have people who reported going to the gym 3 or 4 times, but we don't see that in the data. And then we've got the opposite. We've got people who said they never went to the gym, and yet it looks like they did in our data set. It looks like they went to, I remember looking at this, it was like a CrossFit that somebody had gone to a few times. You don't see it in this graph because it blew the scale, but there was one person who said he never went to the gym, but he had 27 visits to a gym in the database. And so we dug into this a little more. I'm pretty sure he lives over a gym. So this process did not work as well as I thought it would. I thought we could capture exercise behavior and having children, and in fact, we don't see that here. So this process turned out to be a lot harder than I had expected. I think, rather than me coding this manually, I was able to do that with a small study of 21 people, right? But the way forward with this is to train some machine learning models to do this, right? And I'm not really interested in whether they go to the grocery store or whether they go to a daycare. I'm interested in these characteristics of the respondents. Do they have kids? Kind of trying to, questions that my clients now ask in an active way, can I capture that data in a passive way, right? I think in order to really try this, we're going to have to do a gold standard travel diary sort of study to figure out where people went. This is, so this is my future research idea here coming off of this work. The other thing that realization I came to with this work is that, there are a lot of other people working in this area, right? Like Google and Foursquare and a company called SafeGraph, they make money by, knowing what we're doing and where we're going all the time, right? So, like SafeGraph is a company that's, their tagline is, we predict the past, right? So they have all this location data from people, and then they can, say to Starbucks, like, these are the people, so many people walk by your location in Midtown Manhattan the other day. And then that fell on Saturday, and it went back up after, for some reason. There's a lot of money to be made by figuring out where people go, right? Which suggests to me that they've figured this out and they know how to do it. And they've got algorithms that do a lot of the things I want to do. I'm not so much interested in whether someone went to Starbucks, but I want to know a little bit about, like, their socioeconomic status or these kinds of things without having to ask questions. And going to Starbucks and to Target suggests, gives me some information with which to make those predictions. So these companies have a slightly different emphasis and I want to sell to their customers, but I think they figured out a lot of the nuts and bolts of what I'm trying to do. The problem is they're not going to give me their algorithms, right? They're not posted on GitHub. I can't download these things, right? Because they're making money off of them, and so they're, confidential information. At the same time, I can't share my data with them, right? I promised my colleagues that this data wouldn't show it to anyone, so I certainly can't send it to Facebook and ask them to run it through their algorithms. So we've got kind of a mismatch here. They've got secret algorithms, I've got secret data. How are we going to bring these things together? And is there some way to partner with those guys? Because I think they've solved a lot of the problems, rather than me solving them again, right? Why don't they just help me out here? So I'm going to stand still on this for right now. The second study is with Toby and David, and it's about that in-app location data. So for this study, we used an application called Pollfish. Pollfish is a survey app. It will present you with an opportunity to do surveys, and you can then get points or you can get gift certificates or something like this for Amazon. It asks survey questions. It does the active data collection I was talking about, but then it's also collecting passive data in the background. This is what it looks like when you go into the Pollfish app, answer a quick survey for a chance to win. And then this is one of our questions over here on the right edge of the screen. Which of these blogs or newspapers do you read regularly? So we did a study in the spring of this year. We had about 2,000 respondents, and this is a non-probability sample. These were selected from the Pollfish database. It's just sort of the first people who saw the ad and clicked on it and wanted to do the survey. So as I said, it's not representative. It overrepresents women and those with low education. Let's see, this doesn't work. The questionnaire asked some demographic questions, and then it asked 4 political knowledge items and 6 political engagement items. The passive data that Pollfish also collects includes the language of the phone, the type of the phone, the OS, the service provider, the model of the phone. So we've got all this information about the phone itself. And then there's a special delivery of passive data. Pollfish does not usually give this out to their clients, but they gave us a list of all the applications installed on the phone, These are the 4 most common apps among our population. I'm sure many of you have heard of Facebook, Snapchat, and Walmart. Has anybody heard of Dice? I had not either. It is not a popular app in the general US population, but it is the most popular app in this population. I looked into it. It's a gambling app. So you pay money to be able to roll the dice, and you roll the dice by like shaking your phone. And if it comes up with a certain number, you win. And the prizes are things like diapers. So I think this explains why our population is mostly women and mostly low education. So the other special delivery of passive data that we got for this study is historical location data. This is not the always-on location data that I had in the other study. It's that in-app location data. So when you're in the Polefish app, we get your location. It was 304 coordinates per respondent. This is really high, right? Over 9 months, are you really in the Polefish app every day? The median respondent. I suspect that the Polefish app is also maybe in cooperation with the Dice app, which might explain some of what's going on in this sample. But I do have about 300 coordinates for each respondent. I mean, the median coordinates per respondent is 300. So what I'm going to do is impute the 5 variables derived from the questionnaire: the race, marital status, and presence of children, and that political knowledge index, and the political engagement index. So my question here is, if I hadn't asked these questions, could I impute these pieces of information based on that passive data that I have, right? And I'm going to do this separately for each of the 5 variables. The inputs to the models are all that passive data we just talked about. So I need a base of comparison to do this. So I'm going to run first a model that only uses age and gender to predict these things. Not surprisingly, it doesn't work real well, right? But I want to see if the passive data can do better. I needed some base of comparison here, right? So then I'm going to do age and gender and that passive data, all that information about the phone, as well as the applications installed. And then I'm going to use that location data as well to figure out where people live, like which block group they live in. Mannheim is a great place to talk about this. So like which square in the quadrat, right, do people live in Mannheim? And based on that, I can merge in some information about what we know about that area, right? The racial breakdown, the gender breakdown, other things like that. We can look up information about these small areas in the US from the American Community Survey and merge that into the data set. It's not data about the respondent, but it's data about, people who live near where the respondent lives. Now, I don't know where they live, so I imputed that based on the phone's location over those 9 months between 10 p.m. and 6 a.m. So where was the phone overnight? And then I took the modal block group of where the phone was overnight and imputed that to be each respondent's home location. So how do these models work? What kind of gain do we see from the passive data in the imputation? So these are random forest models. I trained them on 75% of the data, and then I tested them on 25%. So what you're seeing here are the percent correctly predicted among those 25% of cases where I tested the model. The open circle is using just age and gender, what I call the frame variables, right? And then I add in the passive data. The passive data contributed almost nothing to the accuracy of the race prediction. It went from, I think, 65 to 67% accuracy. I recently reran these models when I was in Cologne at the summer school, so I'm not sure that I'm quoting exactly the right numbers to you. The graph is righter than the numbers I remember in my head, because I've been running these models so much. So we see a small gain in accuracy, or in the correctly predicted percent, by involving the passive data. When we move on to the other variables, the gain is sometimes bigger. So percent married, or marital status, I can do a little bit better by bringing in that passive data. Whether you have children or not, I actually thought that the passive data would do better here, right? I mean, a lot of the people who I know who have kids, they have like kid apps on their phones, right? So that if the child starts fussing, you can say, oh, here, play the game you like, right? So I thought I thought this was genius. Like, it's gonna work great, because the presence of this application on the phone is going to be a strong indicator of whether someone has kids or not. Turns out not to be the case. I mean, most of our respondents have kids, so there wasn't a whole lot of room for improvement here. The political knowledge, we were unable to improve that prediction at all using the passive data. So this is questions like, how many terms can the president be elected to? Who is the Chief Justice of the Supreme Court? Sort of basic knowledge questions about the US politics. Passive data seems to have nothing to do with that. However, the passive data made a huge improvement in the engagement model, so political engagement. It's a measure of like how much you really care and follow politics, right? And so there's a lot going on there. I haven't looked yet at what variables it is that's actually explaining that, but I wonder if it's things like, you know, the news, having news apps and stuff on your phone suggests that you're the kind of person who follows politics closely. I have that information, I just honestly haven't had a moment to look at which variables are driving these models. So the takeaways there, I think, these suggest that yes, we can start thinking about shortening our questionnaires by not asking some of these questions. This political engagement scale is 6 questions, right? So maybe we don't have to ask those 6 questions, or maybe we only have to ask 1 or 2 of them, and we can get a pretty good prediction of political engagement. And so that's the view I'm taking. Can I make surveys shorter and higher response rates and cheaper by using passive data to fill in some of this information rather than counting on active data? And then the third study, this one is very new and we haven't started yet, but I just want to give you a sense of what we're looking at. And this has to do with the fitness watches. So RTI does a study called Ad Health. It's a longitudinal study of adolescents. They're no longer adolescents, but they were when we first started talking to them. And in wave 5, we asked respondents if they had the Fitbone, the Fitbit, the Jawbone, one of these sports watches, right? Mine's a Garmin. So we asked if they had those, and then when they said yes, we called them back, and this data collection is still underway here, and asked, can we get that data? So can we get a historical record of all the data from your Fitbit or so? And they built this infrastructure to go in and grab the data and merge it with the surveys. So now I've got survey reports of exercise and sleep behavior, and I've got the watches reports, or the devices reports of exercise and sleep behavior. And I want to compare these two. I know that survey reports of exercise are not great because people tend to over-report the amount of exercise that they do. But the devices might not be great either, right? Sometimes you forget to wear your watch when you go out for an early morning run and just don't remember, right? Sometimes the battery dies while you're out, right? So there are errors in both of these sources. I've got error in the active data, the survey data, and also error in the passive data. But the errors, importantly, the errors are really different. They have very different mechanisms. They're going to have very different error properties. And so I want to build a latent class model to try to uncover the truth about sleep and exercise variables. So this is similar to work that I published with Daniel Obrowski and Ante Kirchner and Frauke Kreuter, looking at the quality of administrative data. As I said, I used to be at the IAB in Nuremberg, so we had administrative data on employment, which has errors, and we had survey data on employment, which has errors, and we combined the two of them to try to uncover the true status. We're going to do something similar here. So this is what the model looks like. I've got 2 sources of data, the fitness tracker, the device, and the survey. And from each one, I've got measures of sleep and like low intensity exercise and high intensity exercise. And so bringing these 2 sources together, I can uncover the true, or I can get estimates of, the true values of how much people sleep and how much they do low and high intensity exercise. So this is what we have planned. As I said, data is still being collected, so I don't have anything to present on that today, any results. So the overriding question here was, can we make passive data, can we use passive data to make our surveys better? Like I said, I don't have a true answer yet. I'm not 100% ready to say that the answer here is yes, but I think these studies and other studies that people are doing show that we can be optimistic about the use of passive data to supplement survey data. There is a lot of research that needs to be done. I've shown you what I'm doing. I'd love to hear about what you guys are doing along these lines as well. I think this always-on location data is very powerful. I remain excited about the information that's contained in our always-on location data. We just haven't figured out how to get it out yet. So I'd love any ideas you guys have on that. But hopefully, we can start soon reducing the length of our questionnaires, which should make them cheaper and should increase response rates. And I also think that when we replace active data with passive data, there are times when we can also improve the data quality. Maybe because the survey reports are so error-filled that passive data can just do better, or maybe we can offer our clients that, that combination of, we'll ask the questions in the survey, those have error, we'll get some data from the devices or from passive data, which also has error, and we'll bring those two together to get the best possible estimate. So some clients may say, oh, I only want active. Some people will say, I only want a passive measure. And some of our clients will say, I'm going to need both of those because I want the best possible estimate. So those are the kind of options or alternatives I'd like to be able to offer clients. So there are a lot of things to worry about that I have perhaps not discussed as much as I should have. The accuracy of the sensor data is always a concern. I think as survey researchers, we know a lot about error in survey data. All of us could talk about non-response error and measurement error all day long, right? We don't know as much about error in sensor data, and so we should just be very careful to not assume that sensors are 100% accurate, right? We have to turn that same skeptical eye that we have towards surveys, we need to turn it on these other sources as well. Yeah, you should definitely have a plan before you start collecting this data. My 21 respondent RTI survey, I did not really have a plan. I just thought, oh, they're going to like email me stuff. It quickly became overwhelming just with my 21 respondents, and all that always on location data, it overwhelmed my computer for a week. So if you're going to start doing that kind of data collection, make sure you have a plan and like test it out before you shut down your computer. And then there's a whole issue about security that I haven't gotten into here that I think we need to worry about as a field. Not only when you have, of course, always on location data, there's a real confidentiality problem there. I can't share that data with anyone because it reveals where my respondents live, like the actual address, right? I'm also concerned about hacking. I mean, we hear in the US anyways, we hear a lot about hackers trying to come in and break into corporate servers. I know the RTI servers get attacked regularly, right? If I promise someone confidentiality that I won't share their data and then somebody comes in and hacks it and takes it away, is there insurance for that kind of situation? I'm worried, I don't know. So maybe something to keep you up tonight. And then, of course, we've got selection bias in this data, right? The people who participate in these kinds of surveys and let you collect always on location data are not the same as, the general population, right? So I haven't addressed this issue. It's a big one, and a lot of other people are working on that, thankfully. All right, that's all I have to say about my 3 studies. I'd be happy to hear any thoughts or ideas you guys have. Thank you.
Thanks so much, Stephanie, for this very insightful and interesting talk. So the floor is up for you for questions and also for those listening from
Do we have people online? Yeah.
Thanks, Stephanie. That was very interesting. I was wondering regarding your conflicting matches of the moves data.
Mm-hmm.
Very often that will, of course, be in cities where there's different businesses on top of each other
Mm-hmm.
because you have 2-dimensional kind of coordinates.
Yep.
Would it be possible to kind of get a measurement of the altitude or how high people are up? Because at least some fitness trackers do.
Right.
They give you indications of the steps people.
Yeah, I know. I see that in some of the GPS. They give you an altitude measure as well. I don't seem to have that in the moves data. That is a concern. Actually, in North Carolina, not as much. There aren't too many tall buildings there. But yeah, it's something we're worried about. Mm-hmm.
Particularly, it would also give you a bias that's larger in larger cities where you have
Yep.
more high-rise buildings.
Yep, exactly.
Thank you very much. It was really interesting. I'm a bit wondering about the fitness data.
Uh-huh.
Because you're using whatever device the participant has, right? So how can you compare the data of different devices?
Mm-hmm. Yeah, that's an important point that I don't have an answer to at this point, but I'll write that down. The same thing happens over time within device, right? I don't have a Fitbit, but from what I understand, they will just update themselves. They will go and get new software to run, and then all of a sudden the count steps will be more or less accurate. So I think it's not only a concern across devices, but within devices as well.
question from Bella.
From Bella? Hi, Bella.
Hi, Bella. What are your or RTI's clients' reactions when you propose to use passive data? What are their reactions?
That's a great question, Bella. We're not proposing too much of it yet. I think I feel like I need to have a better sense of what's possible and the accuracy of these different data sources before I could go to my clients and suggest them. So that's why I'm doing this kind of work. In the health field, I think they are a little bit ahead of us. So there are health studies that are using these different devices or giving people Fitbits to track their movement. But outside of the health field, no, we haven't been proposing these to clients yet. We don't think we're ready.
How do you think will this impact on pre-testing? Because you mentioned that, like in the case of the engagement questions, that possibly you can use passive data to replace the scale. So do you think that there will be a shift in pre-testing, maybe not towards like we don't stick that much anymore to understanding questions, but more how can we replace kind of model questions through the use of passive data?
That's great. So you're thinking about the next step, right? So once it becomes clear, yeah, some variables we can replace with passive data. How are you going to figure that out? I have a new survey. Do I need to ask all these questions, or is there some subset that can be predicted through passive data? And how do I quickly determine that before I go into the field and spend a bunch of money I don't have to? No, that's a good point. I hadn't gotten to that step yet, but I like it. So you'd have to have the pretest maybe would be a little bit bigger because you need the power to run these kind of models and figure out which variables can we accurately predict. Yeah.
The first thing that came to mind when you showed the first things you want to impute is that maybe there is even like an easier test to start with, as in things like I'm thinking of there's some modules and surveys concerning safety in the neighborhood. How often do you walk in your neighborhood at night? That would be stuff that wouldn't just be a proxy, but would be exactly the answer to the question. So that would be maybe the first step before we try to figure out, okay, do you go to a care home? Do you go to a daycare in order to figure out whether you have children? Start with how much time do you spend in your neighborhood? Stuff that we actually ask people, which is also probably prone to a lot of bias. I was
a bit confused about how we're going to get a passive measure of how safe you feel, but you're saying just like sort of it's time just spent in the neighborhood, walking around.
People use how often do you walk in the dark in your neighborhood as a proxy of how safe you feel in your neighborhood.
Okay, all right.
Stuff like that.
Yep. Introvert bias.
So Henning has a question. In study 2, you showed that the prediction of political engagement improved when you use passive data.
Yep.
Could you tell us a bit more about this? Was there specific passive data especially predicted?
Yeah, so Henning is looking at that last line in the graph. I can maybe quickly go back to that. Where we really increase the accuracy of the engagement prediction by bringing in the passive data. And the question is, which variables explain that? And I have that data, but the models were running last week still when I was at the summer school. I was giving my students like updates, like, oh, I got the fourth variable. They were crossing their fingers for me. So I just got this to run last week, and I honestly just haven't looked at what factors are most predictive. I should have done that before the talk. I'm sorry, Henning.
I have a question regarding the collection of the location data as an example.
Okay.
When we do a survey in the traditional way, we usually assume that most of the data we collect, most of the questions refer to the point, to the date when the survey is actually done. I'm wondering how you decide the time period for which you need the location data. For instance, how long has it to be? Where should it be before the interview, after the interview, and how should you take care that it's a comparable period across the different persons?
That's
for the basic data, because, for instance, when we think of doing exercises, it probably makes a difference whether you collect it during autumn or summer and so on.
Right. Yeah, that's a great point. I think a lot of the times when we're using passive data, it's going to be less a large sample, a cross-section that we get information about at a given time, and it's going to be maybe smaller samples with a lot of selection bias, the people who consent to passive data, but then once you've got them recruited, you might as well do it over a longer length of time, right? If I'm going to put an app on your phone, it's cost-effective for me to keep you in that sample as long as I can, right? I've heard a bit about what they call like the Christmas drop-off, because people get new phones for Christmas, and then they don't put your app back on the phone, and so you lose a lot of people right around that time. Yeah, I think we're going to have to start rethinking in that dimension as well, how we design these surveys, because you're right, things can change over time. This example here, I just took over that period from June to April, I think it was, or July to April, where the phone was at night, right? But it could be that somebody moved in January of that year, and so this would turn out their old address, because most of that time was at their old address and not at the new address, and that could lead to problems in the models. Yep, it's definitely a concern that we're going to have to rethink how we do these surveys, I think. Redesign them in a more longitudinal way.
Should we be concerned about the possibility that the people change their behavior if they recognize that they are tracked, their behavior is indirectly tracked? Right.
No, I think we should worry about that. And so Ruben has done a dissertation recently on panel conditioning. And so it's sort of like that, right? I know that I'm in this survey. I know that you're doing the always-on location because I had to download that Moves app and consent to it. And so does that change people's behavior? That certainly was a concern. RTI had a lot of concerns before I even did the survey about putting the app on people's phones. And so we had to do this long informed consent procedure. And so they certainly knew what we were doing. We asked in the outtake survey several questions about, did it drain your battery? Did you think about the location data that was being collected? Did you change your behavior based on the data that was being collected? And we only had 21 people, and there was only one person who expressed real concerns and said, yes, I changed my behavior. I thought about it a lot, and I changed it.
I guess my concern is not cleared by the outtake survey, because if I sometimes go to illegal places, wrong places, for example, on cheap, so I regularly go to someone else's place that I should not go. And on-location data significantly changes my behavior. Intentionally, I'm not going to illegal places or wrong places. But I would not answer definitely in the outtake survey that I changed.
Right, it's not a perfectly accurate measure, for sure. I'm just saying we had tried to address that, and the limited evidence we have suggests that it wasn't a problem among these respondents, but it is something I would worry about in a real study, for sure. RTI was concerned that what if there was like a series of murders being committed in the area while we were doing the survey, and then it's an interesting point that I hadn't thought of, right? So what if there were some murder, like a serial murderer running around, right? And we had all this data on where respondents were. Are we legally required to dig through that and look and make sure, our respondents, this person was coincidentally at all those places where the murders occurred? And would we have to turn that over to law enforcement? I think there's a lot of important issues like this. I mean, the issue you brought up, but also sort of legal issues as well that we need to think through.
I think part of the problem is a little bit definitions. I mean, maybe one key issue is that you're tracking the phone's location. You're assuming that's a personal location. You already commented a little bit about the proxy element of the passive data, but this will be the same case. And in international research or comparison would be even harder to assume the same definition. I would think about places where you're talking about the issues of security. You won't take your phone out for if you go into a place where maybe it's dangerous. You will leave, or you will have multiple phones, and then you will have to track the person with multiple phones if you want to have the same person. So in that case, actually what you have is location of a phone. Someone admittedly possessed, but could also share with the whole family. So I think that's part of the definition behind what you're actually tracking has to be reflected of what you're trying to explain at the same time. And the second is, it seems that I like the title of your presentation more than the actual
content.
What you said. But what you actually said, because I think you started the presentation saying, okay, they're trying to substitute survey data but the title says supplement.
Okay.
Survey data.
Yeah.
And I think it's more about what could we know with this data that it's really hard to ask, like for example, you talk about religious attendance, but also I'm thinking about segregation, for example, contact of a person during a specific time. It's really hard to ask in a question, and there is an interest also in survey research to know to what extent the society is segregated in especially in cities or rural areas. So maybe that kind of information would also tell us, for example, if a specific group of people that you will also know that there are the race, age, many things that you can ask, and know, for example, how people from different groups or different classes, different states, get in contact in a specific geographical area where you should actually expect to have this kind of contact, maybe political affiliation and so on. So I think it's more about the supplement, and I missed that. So I actually got confused.
Well, the third study is more the supplement, where we're going to bring the two sources together. The first two really are looking more at replace or substitute, and the third is more the supplement. Yeah, no, those are good points. I mean, I like the cross-cultural differences in phone usage. I think that's an important piece that I hadn't been thinking about. I think most of my RTI colleagues are like me. It's me, it's my phone, nobody else has the password, and nobody else is going to carry it around. But as we broaden and try to get a wider swath of the population involved in these studies, yeah, we need to consider the fact that people use their phones in different ways. Yep, good point.
Yeah, I think I agree also with Roberto that you should be also careful about the cultural variability, but not only in the use of the phone, but also in the variables of interest, because as you mentioned, kind of the religious service attendance, it is different across religions. For example, a Catholic is expected to go to church every Sunday, but this is not necessarily the case for Muslim women. So they are not expected to go to the church.
And not on Sundays.
Yeah, definitely. So that is also important.
Yep. Yes, we tried to do a deeper analysis on the religion question. We asked people if they had been to church the last Sunday, and then we looked into the data to see if we could find it into that in-app location data, and it just wasn't there. It turns out, I mean, it looks like people aren't using the Pullfish app when they're at religious service, which makes sense. Yeah.
I think you could also have a bias because people who are very religious might consider it inappropriate to take their phone to church. I mean, in my little village where I grew up, that was definitely the case. That would be, no, you cannot take your phone to church. And even if you said it's on mute, no, it's nothing that belongs in a church. So what you're trying to measure is how religious are people, and you might get the exact opposite of, yeah, those who are really religious will never show up in church with their GPS tracker.
Good point, thanks.
Maybe as an add-on to the supplement of the different data, I'm wondering if one couldn't use the objective data or the passive data to make the subjective data better. I mean, if I knew I'm tracked, my fitness is honestly tracked, and I'm asked at the same time at the end of the day, how much did you exercise today, I probably might be more accurate in my subjective.
Or you might exercise more. I mean, that's kind of the panel conditioning.
Yeah. Well, yeah, of course, but still, if I'm, maybe it's, you could use, or one could use the passive data to make the subjective data more accurate. I mean, that people might change their behavior when they're tracked. That might be the case even if you only use subjective data, right? If you ask people every day how much did you exercise, that has nothing to do with if it's passive or active data. But maybe that's also something what gives passive data a bit more power. So you could use them, and you don't even have to use them in the end because they are just a mean to make the subjective data better.
Okay. Yep, I have done some work on that issue when I was at EAB, right? So if people think that you're going to check up on their answers in a survey, do they then give better answers because Or do they give actually worse answers? I know you're going to check up anyway, so not going to even think about this. I'm just going to pick the first answer choice, right? Yeah, that's a good point.
About your two models here that you compare, you use them.
I'm sorry about my
two models that you compare. The one where you have only age and gender. I wonder whether your results would change in any way if you added education to the first model already, because education is sometimes quite predictive. And since you find the huge gains in terms of political engagement, we know that particularly political interest and newspaper reading, etc., is highly influenced by education. So I wonder whether it's a real gain of the passive data or whether it's also omitted variable bias kind of.
Right. I mean, yeah.
The traditional.
All those gains are very much dependent on what you put into that the first model. Age and gender are just what Pollfish has sort of about everybody. So if you didn't do a survey, you would already have age and gender, and that's how we pick those. But yeah, I can throw education in there and see how that works. Yeah, we should have it for all the survey respondents. We asked that question.
Thanks for the talk.
Thank you.
I would like to come back to the accuracy of sensor data. So as you pointed out, so you didn't talk so much today about it. But when it comes to sensor data, so in my opinion, so the accuracy of sensor data is highly based on the device and some different aspects like the internet browser. It's about the technical aspects. So when we try to evaluate measurement equivalence in surveys, for instance, for response scales with 5-point, 7-point scale, it's quite simple to conduct these analyses. But when it comes to sensor data, so there are so multiple differences with respect to the devices, so that I think it's quite hard to make sure that we measure the same across different devices.
Yeah, there are people developing those benchmarks, like for the step trackers. One of my colleagues at RTI has written the standards for that.
So for instance, just with respect to acceleration, so we just take two smartphones together and collected the acceleration while we just shaking the smartphone. And what we found is significant differences between both smartphones, which was associated with the sampling rate. So the one was the iPhone, the sampling rate was 16 measurement points every 16 milliseconds.
Okay.
The other one was just this one, so it's a quite old HTC. And it has a sampling rate of I think it was 124. So every 124 milliseconds we got a measurement point. So now it's quite hard to say are these measurements comparable or not. So my interest would be how you address this issue at RTI. This also applies to GPS and other sensor data.
Right. Yeah, I'm working on a paper with someone who did a very similar study with the GPS devices in a car, had like 6 GPS devices laid out and drove around New York City and looked at the variance on those, and also had the really big one on the roof that's supposed to be the gold standard. So yeah, this is definitely a concern, and maybe, I don't know that we have the data to do it, but maybe this model is the answer, right? So this could be like the different devices, right? So not only fitness trackers here, but the Fitbit, the Jawbone, the Garmin, right? You could build this model based on those. You'd really need, this model requires that you have all variables measured from all sources, right? So this seems to me to be the best way. You put me on the spot here, but this seems to me to be a way to measure the differences of the different devices, and then get a sense of like, what's the function between the Fitbit and the true values, and the Jawbone and the true values, and try to develop an adjustment factor. That seems to me to be one way to address the issues you're talking about. You guys are raising all really good points, and I don't mean to punt on all of them. That's a football metaphor, an American football metaphor. Sorry, I don't mean to ignore them. I haven't addressed all these issues yet, so I think that's a really good point. But I don't have an answer on how we're dealing with it right now. The challenge at RTI was really just like putting together the database that could handle the data from all the different sources, right? Fitbit data looks very different than Jawbone data and different than Garbone data. And so just building the database structure to put them all together, we were very proud of that. So.
I think it's not that you don't have the answers. It's that this is the kind of.
So you guys are really good at asking questions.
Things we have to discuss, things we have to find out. I thank you once again for being so transparent also about your findings, and thanks again. If you don't have any further questions, I didn't see any. We have colleagues here before you go and leave the room from the University of Mannheim who want to say something about such a survey.
Yeah, because we're actually, I'm Laura, I'm from the Arbeits- und Organisationspsychologie Lehrstuhl for Work and Organizational Psychology, and we are currently collecting data on a very interesting study on health behavior at work. And we are actually doing a daily survey study where we supplement our daily survey data with some passive data.
Okay.
And we're currently looking for participants.
Respondents.
So we're looking at adults who would like to just take part. And I left some information flyers right on the table over there. So if you're interested, please feel free to just take one or to come directly to me if you have any questions. I'm happy to answer them. And well, yeah, we try to solve some of the problems you also raised, but we also face lots of those problems with data. And it would be great if you could help to find out how to actually do it in the field and answering some important questions. And everyone who's taking place and some of the people will get some activity status from us for a time of 2 weeks. They will also get the information on their own activity over the 2 weeks, so as a little bonus.
They can test it whether it's true or not.
Yeah.
Thank you, and once again, thank you all for coming.
Thanks, everybody.